Hello, everyone. My name is Ivan Sharmok. I'm a solutions architect or solutions engineer at Tigera, the company behind the project Calico. So in today's session, what I want to go through and to demo is how to configure, how to use Calico for Windows, how to provision the infrastructure, configure Calico, and then configure Windows host and join them to Kubernetes cluster. So for those who are not familiar with Calico, I'll briefly describe what Calico is, or Calico, or Project Calico as it's known on the open source community, is a Kubernetes CNI and security solution for Kubernetes platform. It can span beyond Kubernetes as well and cover hosts outside of Kubernetes cluster, but that's more complex configuration that we are not going to touch in this session. The solution itself is highly scalable, provides highly scalable networking. We've been tested across hundreds of thousands of clusters. Calico provides the best-in-class network security and can span from containers all the way to the bare metals. This slide briefly shows you who is using Calico. And in fact, if you take a look from the left, on the left-hand side, we have public cloud providers, well-known, at least in the North America, the Amazon, Google, Azure, and IBM. All of them have integrated Calico into their managed Kubernetes offerings, and in some forms from using Calico CNI and with Calico security, or just using Calico, leveraging Calico security engine to provide the security options for Kubernetes. Also, we offer it or have been integrated in managed solutions, on-prem solutions, such as either upstream Kubernetes or something like Docker Enterprise, which is distributed by Miranda's team, or Red Hat's OpenShift, and as well as included in as an option in Rancher or Canonical, VMware Tanzu, D2iQ, and all the way moving to the right in here, it can be used on-prem, VMs, and bare metals as well. So the range of where Calico can be used is pretty broad, depending on what requirements you have. You can use that. So agenda for today's session is to go through a few considerations, and it's very briefly touching on some of those, especially around Kubernetes and Calico networking, because the networking topic by itself is very vast and very can get pretty complex. So in this session, the main goal is to show how to configure Calico and then configure the Windows hosts and join them to Kubernetes cluster. Then I'll switch to console, and probably most of the time after that spent in the console, setting up the provision and the infrastructure, setting up the Kubernetes cluster, configuring Calico, joining Windows host to the cluster. And as the end result of that, we'll do some simple connectivity tasks between the pods, Linux to Linux, Linux to Windows, Windows to Linux. And if we have time, I will go through some examples of network policies and show you how you can shape the security for your workloads in Kubernetes using Kubernetes network policies as well as Calico network policies. All of the content for this session is published to GitHub. That's the URL to where you can find it, or if you go to Tigera Solutions in GitHub and just search for Windows key, just use Windows keyword. I think there's at this moment just a single single repo in there where you can get the content. And this session has been previously recorded. I used AWS infrastructure in that session. So if you are looking to use AWS for your infrastructure, then you can jump. You can view that recording in Tigera's YouTube channel. Okay, so a few brief considerations when building Kubernetes cluster is, one is what pod CIDR you're going to use, the CIDR size, and whether you want it to be routable or non-routable. In majority cases that I've seen, typically the CIDR is selected to be non-routable because /16 is quite big network. And if you want that to be routable, you have to integrate it with the existing network you have and orchestrate the management of that, which is doable, but that requires a high degree of organizational management of networking in your stack. The service CIDR, another consideration for that one. Here you can see the values, like for pod CIDR is 192, 168, and for service CIDR 10.96. Those are defaults. In fact, kubeadm, the tool that I'm going to be using to set up Kubernetes cluster, that's what it uses by default, and Calico is configured to with default values. That's what Calico uses as well. And one note in here is that kubeproxy has a limitation on Windows. It can handle only a single IP block per host. The Kubernetes domain in general is very fluent, so things are changing rapidly in there. Windows is especially kind of trying to catch up with all the capabilities offered by containers or container platforms. So this limitation could be lifted in one of the next releases of Windows, but at the moment, that's something to be aware of, especially if you're building your Windows clusters. Just know that you have only a single block in there, single block of IPs for each Windows host. One reason where it needs to be considered is that by default, Calico uses /26 blocks, and that is configurable. If you're using Calico CNI, you can select a different size. And keep in mind that on Windows, first 4 are reserved by the operating system, by the Windows host itself. And you have / whatever network you selected range you selected -4. Network encapsulation, you cannot, from Calico networking considerations, when you get to network configuration, things to be aware of that IP and IP encapsulation is not supported on Windows, or I should say in Azure. One reason for that is Azure uses that protocol internally. So you cannot really use that when you're building your Kubernetes network. However, we have support for VXLAN as an alternative overlay network. So you can use that option, or you can use just native BGP. In fact, Calico, I believe at this moment, Calico is the only one who is offering the native BGP configuration for Windows for Kubernetes platform. You can also choose the initial IP pool CIDR, and that's what I previously said, like in this slide, where you have the pod CIDR that you need to select for your Kubernetes cluster. So when you configure in Calico network, that should match. I believe since, I think in version 3.14 of Calico, or 3.13, we've added the automatic detection of the pod CIDR when you're using kubeadm. So if you're using kubeadm to provision and install your Kubernetes cluster, then you should be fine. If you're using some other methods of installing Kubernetes, then make sure that the pod CIDR matches in Calico configuration. And also NAT outbound. That's configuration, that's the setting in Calico IP pools that you can configure to make sure the traffic that is going outside of your host is NATed. When you have several nodes in there, that makes sense to a no-brainer to set up the NAT outbound. So host-to-host communication is handled by the networking stack of the cloud provider. If you use routed network, then you can handle that yourself. I'm going to check. So there are a few questions in here, and I'll cover those once I get through the slides, and then the rest of the questions that come up, I'll answer at the end during the Q&A.
I've been getting to them as well, Ivan.
Okay, cool. Thank you. So about the Windows hosts, Windows 1809 core, which is Windows 2019, Windows Server 2019, and specifically the build 17763. That's the first one that includes necessary fixes to have the CNI or the networking stack on Windows working properly in Kubernetes. My recommendation going higher, at least 1903 or 1909. In fact, in today's session, I'll use 1909 version of Windows Server. Pay attention to those build numbers because you need a build number, either that or higher, to have the networking stack working properly on Windows hosts. There are a few dependencies, remote access feature, which should include routing and direct access VPN, sub-features of that installed on your Windows host. We are leveraging, especially for the BGP setup, we are leveraging those features to create the network connectivity. As we'll prepare the Windows hosts, I'll show the download of the Kubernetes components. They depends on the version that you install, and so when you're configuring, pay attention to what you're downloading. And another thing that I want to mention, if you are going to do to use kubectl or kubectl to run the commands like exec command against your Windows containers, make sure to open the default kubelet port 10 to 50 on your Windows host. Just briefly touch on Calico Enterprise, which is a product built on top of open source Calico, which is catered more to the enterprises to solve the enterprise problems like day two operations, more visibility and troubleshooting tools, the external access controls and things like that. So we have a trial offering for people who are interested to try out those features of Calico Enterprise. You can go to tiger.io/trial. For some reason cropped a little bit. You can go to the tiger.io/trial to get a free environment for you to try out Calico Enterprise. Okay, at this point, I'm going to switch to the console, and as I'm getting out of the presentation, let me know if you lose the Okay, so first thing that I'm going to do during this session, just to save some time, I'm going to use the scripted approach of building it. I've detailed in the README file. I have the instructions how how to do step-by-step manual installation of all of the pieces, or use a scripted approach. And I've created a few scripts for Azure as well as for AWS at this point. You can just use the provision cluster script that goes and creates the infrastructure, and then it creates a few helper scripts that you can use to quickly provision the cluster. So in today's session, what I'm going to use is my Azure installation provision cluster script. And in order to do that, I need to get a few, actually, let me pull up the, so on the GitHub, in the repo itself, as you get to the provision in the cluster, you have two options in here. So if you get to the Azure option, here there are some prereqs or some considerations that you can go through, like choosing the image. Here's the image that I'm going to use today, the Data Center Core 1909. To set things up, I need to configure a few variables to pass into my script. That's what I'm going to do. I have already them. Variables. Then just run the script, which will take a few moments to provision. And I'm using in this approach, I'm using the ARM or Azure Resource Manager template to build my infrastructure. So that's going to take a few minutes. What I'm going to do right now is to just show you my ARM template, what I've configured in here. The template itself, there is nothing too complex in here. I did create an ability to provision multiple masters, workers, and Windows nodes. If you want to configure the use different type of operating system or Linux distribution, in other words, for your Linux side, then you will need to go and change the image directly in the template in the VM configuration for the Linux side. Yeah, in fact, it's worth mentioning that in order to set up or add your Windows hosts to Kubernetes cluster, you still need the Linux side of the cluster, because at this moment, Windows does not fully support all the components of Kubernetes to be run just within the Windows environment. So part of your Kubernetes cluster has to be installed in Linux. So your master's control plane should be in Linux. The rest can be Windows, but we recommend setting up at least one or two workers, Linux workers, that will be dedicated to Calico components. Because if you install everything on your control plane, then you'll have to properly size your control plane nodes, because some of the computational power and networking resources will be taken by Calico components. So for the best performance or to create the best reliable cluster, it's better to have at least a few Linux workers in there, so that Calico components can be scheduled from those. So within the ARM template, you'll find the definitions for a virtual machine. For instance, this one is for master, and there is one for workers as well. And here's the part for Windows. One thing that I want to mention, that the Windows machine is configured with a script extension, which does some preparation steps that you can configure manually. They are mentioned in the manual steps, but to automate and speed up the provisioning of the infrastructure, I created a script that is pulled from this repository. So if you are using the script in your environment, just make sure if you clone this repo or fork it, make sure to change the script if you want to adjust anything. If no, then by default, the script within this repository called configure when node ps1, the PowerShell script will be executed as a part of your Windows provision. Will configure, will set up a few components. Yeah, there are a few parameters that you can tweak to. One of those is here's the artifacts location. Right now, it's pointing to this repo, to the config folder. If you want that to be pulled from the repository or any resource that's publicly hosted, then you'll have to adjust this. Okay, so let's take a look into Azure. In Azure, I have my resource group called Calico webinar. So if I look inside of it, there should be a few resources getting created. Yep. And if I navigate and take a look into my deployments, I can see there's a deployment that is running right now. And I believe it's probably at the stage of, yes, installing my custom script on Windows. So you can see all my Linux part has been provisioned already. So let's, while it's running the Windows script configuration, let's get to our Linux part and start working in there. So one thing that I want to do is to get my public IPs for the nodes. Here's my master. Here's my worker. Looks like I still don't have the nodes ready. Okay, so this is still running. Okay, so this one's ready. Master's ready, and Spark is ready as well. Okay. So here I got my master node on the left, worker node on the right. Both of those are Linux. So the next step, let's take a look into the instructions. So the next step, here's the scripted configuration. That's what I'm going to be using right now or during this session. So one first thing that I want to do is to upload a few files. I'm going to use my master node as a intermediate server or like a jump box to upload some of the assets, specifically Calico for Windows zip file, which contains Calico bits. And a few helper scripts that I can then use on Windows side to automate configuration of the Windows node. So what I need for that is to get my set up my SSH key and Calico zip path. So let's jump back to, okay, so my cluster has been provisioned. You can see that this is the output of when the cluster is provisioned. In here, there are a few helper scripts that are generated. And I'm going to use this one as the first one to upload necessary resources. So let's do SSH key. Calc zip, I have it. Yep. Okay, so a few files, a few helpers uploaded, and Calico for Windows will take about a minute to upload, but I can go to my master node and start configuring the master node. So in here, the first script that I need to use is to prepare master, helper prep master node. So let's get the script enabled in a minute. What it's going to do is it's going to download a few files like Kubernetes bits for Windows. And the reason I'm doing it through the Linux node because I discovered that when I pull the zip on Linux, it takes a lot faster than on Windows. Not sure what's happening in Windows. Maybe I need to use like some specific client to pull the file from the web and configure some parameters in there, but it's been taken in there for like 10 minutes to pull it. So that's the reason I'm doing it. In your environment, obviously, you can use whatever preferred way you want. I'm going to use this cluster config in my kubeadm command to configure it. If I show you what's inside, it's just kubeconfig configuration for my cluster. You can see my service subnet or service CIDR, pod CIDR. And for control plane, I'm using the IP of master because I have a single node. When you configure that for production or for environment that has multiple control plane nodes, that will be your load balancer. So for my kubeadm command, it's right here somewhere. Just my command. It's going to take a few moments to set it up. kubeadm pulls necessary Kubernetes images, then sets up, initializes and sets up first node, which is a master node. After that, you get commands with tokens to join either control plane nodes, known as masters, or the worker nodes to your Kubernetes cluster. And if you're doing this manually, all the steps are right here in the description, how to configure which commands to run or how to pull the tokens. So what I can do for now while setting up is to prepare my my windows. Actually, this is done. So what I'm going to do is to grab the token, the command to join a worker node. And if you're using KubeADM, pay attention to which command you're grabbing, because the first one will be joining a control plane node. The second one will be joining your worker node. Make sure that you also either use the root user or use sudo command to join the node, because the elevated permissions are required on the workers or additional nodes that you're joining to the cluster. So once it's done, let me, I forgot to do this, just to copy necessary files so that I can do kubectl get nodes and take a look how many nodes I got. Okay, so I have a cluster with one master, one worker. You can see the status saying not ready. If you go and dig into the node, like describe the node, you'll see that it's not ready because CNI is not installed, and that's going to be next step that we're going to do. But before I do that, what I want to do is to grab the kubeconfig so that I can run the commands from my workstation instead of from the remote server. And I have a kubeconfig file right here. So now if I switch back to my shell on my workstation, I can run kubectl get node. And so the reason it actually worked, because I already exported my kubeconfig variable. So you can see I have the same view from my local machine. Okay, so next step is to configure, install Calico on Linux side, and then configure the Windows nodes. One important thing in here is you need to make sure that Calico is already installed on the Linux side before you start joining your Windows nodes. You can join them before that, but you won't be able to use scripts that Calico provides, because Calico scripts expect that to be already configured. So if you do everything manually, then yes, you can do that, but that will require you a lot of manual steps. So one thing in here, to install Calico, I'm going to jump to the instructions where I go through the installation. So the first step is to pull the configuration YAML for the Calico configuration. Let's take a look. We got our Calico YAML file right here. Since we are configuring this, one more time, just to iterate that, since we are configuring this on Windows, IP and IP has to be disabled. By default, Calico is configured with IP and IP encapsulation or overlay. Windows and Azure does not really support that. So we have to use either VXLAN or BGP. I'm going to use VXLAN in here, so I need to do a few things in here. One, let me show you this part. So here's my Calico file. If I jump to the configuration, you can see I have two variables in here. My IP and IP, which says always, and my Calico VXLAN, which says never. That's the default configuration. What I'm going to do right now is to I'm going to remove the replace my IP and IP with VXLAN, since it's already configured to be always, and just strike down the second one, the second option. So here's my two commands, set commands, and pay attention that this is Mac format for these commands for the set. If you're using this on Linux, then that format will change a little bit. So if I take a look into my file right now, you can see that VXLAN is configured as always, and the other setting is gone. So the second part that we need to adjust is to configure, make sure that our Calico backend is configured to VXLAN. By default, it's Bird. Bird is a component of Calico. When you're using BGP peering, then we use Bird components to configure and set up BGP routing. Since we're using VXLAN, it takes care of all the routing, so we need to disable the backend from switch that from Birds to VXLAN. Again, using set command to do that. And two more things that I need to change also related to Bird is to disable my readiness and liveliness checks for Bird Live and Bird Ready. Let me show you those. Here's Bird Live, here's Bird Ready. I need to make sure I strike those down since I'm not using the okay, you can see those have been removed. Great. So next step is just apply my Calico YAML. So what, just want to show you that right now, you can see there are several pods that are running already, and they have IP addresses, and those IP addresses of my nodes, which means those pods are using the host network. And typically, that's control plane pods that are allowed to do that. For nodes to use for containers or for pods to use the host level networking, they need to be executed in privilege mode or given the permissions to use the host networking mode. And typically that is configured for the that is allowed or configured for control plane pods only, and the rest of the pods usually use the networking provided by the CNI within your Kubernetes cluster. So now you can see 3 pods got the 192.168 IP addresses, and you can see the ranges of those. So one way you can tell that pods are hosted on different nodes, you can just take a look at the mask or subnet of the of each pod, the IP address. You can see 168, 1 and 2. That suggests that 168 has been allocated to one node, while 95 has been allocated to different node. If you remember, I was telling that Calico has, by default, provides the /26 range for the nodes, and that's the slices that getting allocated to different nodes. Okay, so next step for us is going to be to configure the Windows node. So I'm going to jump back to my instructions right here. And what I need to do next is to run this helper prep WinNode script on Windows site. But before I do that, I need to make sure I have my SSH key on Windows site. And again, this is only a requirement if you're using the scripted approach, because I'm transferring some files between different machines right here. So let me get to the Windows. Here's the IP for Windows. So Windows opens up in or the remote host opens up a new display. Can you let me know if you can see it, and if possible through voice, not in chat? Can you see the Windows CMD command line? I didn't hear any response. Can you guys still see the Windows remote session, the RDP session?
Yes, you can see it, but I don't think that the audience can unmute themselves on this platform.
Okay, got it. Sounds good. Thank you. Okay, so on the because I'm using the core version of Windows, I don't get all the UI in here. So for those who haven't used this before, this is the view you get once you RDP into Windows session if it's a Windows core. So all you get is the CMD, which is default command line, default shell, and then you can switch to PowerShell, which I just did. And what I'm going to do just to get my blue PowerShell console in here, and start configuring this node. So first thing that I need to do is to transfer my key, my SSH key, so that I can go and grab the files from the master. And Notepad is still available, so not all the UI is stripped out. Some of the, let me just put it right. So, and what I'm going to do in here is to copy my SSH key, install it in here. One thing that I'm going to do in here is to make sure I remove the txt, the secure copy command on Windows, which was included, I think, in 1809 or maybe 1903. Windows doesn't really like the extensions for the key. So I need to make sure I rename that to compatible format, which is no extension, like this. And then I can continue with the configuration. Need to set up a few variables in here. And master IP. Okay. So at this point, I can just run get all the files that I need. Which happens a lot faster if I download those separately. So next two scripts, one is preparing the Windows node, the other one is configuring Calico. For the first one, the prepare the Windows node, this script does not really need to be run. So that's why I have a check right here if those features were installed, because these features are installed as a part of the provisioning of your Windows nodes through the script that I will show in the custom script. But it's provided as an example to show you which features you need to be to install. Oh, looks like I didn't set up the variable correctly. Yep, that should have been skipped. Okay, so let me rerun this from here. Okay. Okay, so this this script goes through. If you open it up and take a look, right now it's configuring VXLAN networking on Windows for the Calico part to be VXLAN, and modifies a few of the Calico files. So you can see right now it's extracting, building the image, but up here you can see the file has been downloaded and extracted. So all the Calico bits, while it's doing that, let me show you where the Calico bits are. If you get to C drive and take a look in the root of C drive, you can see Tigera Calico, and you can see K. K folder is for Kubernetes bits. That's by default. Community decided to use C drive K folder. So everything Kubernetes related is going to be in there. Everything Calico related is going to be in the Tigera Calico. So if you want to take a look at the log files, take a look at the configuration, just take a look and explore the files in those folders. You can see there's a CNI folder in each of those. Once the Calico starts, you'll see the logs will show up. Calico side logs are going to be in Calico folder, and Tigera Calico, and Kubernetes is going to be in K folder. If you CNI plugins are getting downloaded before the CNI will be configured, they're not necessarily used in here, but they provide you an ability to choose which CNI you want to use for this. Within this demonstration right now, we're using everything Calico. So right now you can see the configuration of Calico is running. It will start the kubelet process and then kube proxy once everything is set up. And what typically happens also, there is an intermittent interruption of the network when Calico is configured. That is due to the some sensitivity that Windows networking stack has. So you can see that right now. And now you can see that second window has opened. So here's my kubelet process. Everything within this scripted approach is leveraging some of the Calico default scripts supplied, and some of the scripts like helper scripts written specifically for this setup. You can explore those scripts and adopt that to whatever process you want to follow. So there is no prescriptive processing here, just a setup of what needs to be done on Windows in order to configure the Windows host for Kubernetes. So one thing to note in here, you can see the one of the windows is saying waiting for HNS network to be created. Before networking is fully provisioned and kube proxy can launch, Windows requires a pod to be created. So in a lot of configuration steps, you'll see a step saying go and launch any pod on Windows just to help that network configuration to be completed. So what I'm going to use in here is to do same thing, just run a local pod that is gonna output each echo echo hello, and then terminate. So what that will allow me to do once it's created, it will allow to launch the kube proxy. So right now you can see that HNS network service has been set up, and here's my kube proxy. So after this, once this is done, on the, if I do, okay, get node, I should see my windows in here. So you can see all three of my nodes, 2 Linux, 1 master, 1 worker, and 1 Windows worker, all part of my Kubernetes cluster. So the last thing in here, what I wanted to show is to deploy some test applications and test the connectivity. So one thing that I can do in here is to get to the top of the folder, because that's where my apps are stored. Here's the structure actually. And deploy my Nginx stacks, then IS stack. And then a utility pod, which uses a netshoot image. It's kind of like a Swiss Army knife of network-related tools for troubleshooting, testing. And I'm going to use those to run a few connectivity tests. So for netshoot and Nginx, they typically set up pretty fast. The Nginx, I believe I used Alpine image, which is very slim, very tiny. Nginx is a little bit bigger, many tools in there. And Windows image can take, I think, up to like 3 minutes or maybe 4 minutes to set up. Sometimes it's faster, sometimes it's slower, but the image itself is a lot bigger. So it's going to take probably next 60 to 90 seconds. While we're doing that, waiting for IS to be set up so that we can run some connectivity tests, I probably can answer a few questions. And Andy, is it possible to unmute people, or everything is through the chat?
We don't have any questions coming in yet, Ivan.
Okay, sounds good. Yeah, if you have questions, please post them to the chat. I myself or Andy, Tiger team will try to answer them. So while it's waiting for that, let me show you another thing in here. So we almost out of time, but I've added, this is a recent addition to this repo. If you are going to watch the previous recording, which was for AWS, this section was not included. Now there are a few example policies that you can use to see how you can manipulate or how you can use the network policies to secure the connectivity or the traffic between services within your Kubernetes cluster. So if we have time in this session, I'll go through this as well. If not, then you can run on your own this examples, this test, and explore those policies. I created several Kubernetes policies as well as Calico policies so that you can see the differences in those, and run the tests and kind of play with those to understand which ones fit which scenarios. Okay, so for okay, so my IS image has been downloaded, so that should be up any moment. Okay, so it is up. So let's run the connectivity tests. And I've created the one-liners in here so that I don't have to get into each pod to run those. So the first test from within the netshoot container, I do an NS lookup, the domain resolution for my Nginx service, and then run curl against that. So you can see the connectivity passes. I can use, in fact, I can use my Kubernetes cluster AP service to curl and to resolve my Nginx workload. The same thing for the same test for IIS. So you can see I can resolve my IIS service and get the 200 OK. And so next test, I'm going to run the connectivity test from within my IIS pod. So I'm going to get the, since it's a deployment, I'm going to get the pod ID, and then run that from within the IIS using PowerShell. Windows pods typically take a few seconds longer than Linux pods. That's, again, the difference in the stack. Okay, so that passed, and here's the test, connectivity test, or the ping. I'm using test net connection commandlet in PowerShell, which is analogous to ping, but it uses TCP/IP instead of ICMP protocol. So running that just to make sure that I can get to the service, Nginx service from within my Windows container over port 80. And again, that's going to take a few seconds. And you can see TCP test succeeded. That's all fine. And let's run the curl command from within my Windows to the Linux pod. Here I'm getting the result. So, okay, so my connectivity all is working fine. I would like to show you the policies as well. Andy, do we have time to record this further? Or is there a hard stop? Oh, actually, Andy's left. So then that means I have time. So for the policies, I have several policies created in here. Anything that starts with a K8S, that's your Kubernetes style policy. And you can take a look in here. For instance, the allowing ingress, all ingress within your cluster. Or here's the policy that I'm going to use the allow DNS for the egress to get to resolve the all the DNS lookups within the cluster. And here's an example of Calico policy, for instance, allowing all the ingress and egress within your cluster. One difference that you can spot right away is this order field in Kubernetes in Calico policy. What that allows you to do is to order your policies and allow some policies take precedence or be evaluated before others. In Kubernetes, you need to do manipulations within naming. So all the policies, Kubernetes policies, ordered alphabetically, or alphanumeric, and in there, if you create a policy, two policies that take an action over the same packets, over the same traffic flow, then whichever comes sorted first will take the precedence. In Calico, you can leverage this order field if you want to rearrange those things. In Calico Enterprise, there is another layer to that called tiers, where you can create tiered approach or stacked approach to policies, and you can grant access to different teams, for different teams to different tiers, and allow them to manage policies only within those tiers. So that allows you to kind of like security team will set up whatever requirements they have or standards for the network, and then allow the next team, let's say platform, to come in and create policies, what they typically do for their requirements and so forth. So first thing I'm going to do, actually let me show this. In Calico, in the DNS policy that I'm using in here, I'm using the label pattern. So I have to match, I'm using namespace selector, which matches against the label, which means I need to have a label for this label to be defined for the namespace which I'm targeting. So by default, Kubernetes namespace does not have that. So if I copy, here's my commands to get the labels. The DNS pod resides within the kube system namespace. So if I list or render the namespace with labels, you can see there are no labels. So because I have this already tied in my policy, that that label, I need to apply that first. So what I'm going to do is to apply, I'm going to label my kube system namespace and then render it. So now you can see there is a label in here. So the next step is to deploy the policy. Okay, so my DNS policy has been deployed. And test the connectivity. So I'm going to run the netshoot, from netshoot, try to resolve the IS service, and then from within IS pod, try to resolve Nginx service. So here's resolution of Nginx, and here's resolution of IS and Nginx. So both of those worked. What now happens, because I have a policy now saying that for my namespace, there is an egress policy that explicitly says allow access over a certain port, which means now there is no policy allowing pods to egress over other ports. So if I try to test, let's say, curl from netshoot to Nginx, see, I can resolve my domain, but I cannot run curl part. So this part of the command didn't work. And to resolve this, I can do next set of policies. So now next set is to allow IS egress to Nginx. And let's take a look into that. So in here, I'm saying that my policy should apply to pods that have this label, run IS. This is egress policy, and that I'm on the egress, the destination of this flow should be to the pods that have label run Nginx, and that's over port 80. So let's apply this. And the second one is for ingress from IS. So let's actually take a look into that as well. So on the other side, I'm saying that apply policy to pods with the label run Nginx, but this type of policy is ingress. So when you're using ingress instead of to, which we had for ingress right here, we have from. So we're saying we allowing traffic only from pods that have label run IS. So the flows that are coming from IS, any traffic, will be allowed over port 80. So let's do this. And now let's test from IS trying to access my Nginx service. So now I have my connectivity, I can do that. But if I do this, again, from my netshoot container, so from Linux container to Linux container, I don't have the policy explicitly defined, so I cannot get to that service. So that's one example. And here's the second example is to allow access allow netshoot container or pod get to IIS. So find this policy and then run the test. Okay, so I can, from my netshoot, now I can get to my IIS. Now, taking this one step further and leveraging Calico policies. So for Calico policies, I created Calico policy for IIS ingress that allows anyone to talk to IIS except netshoot. So right now we tested that my netshoot can get to IIS. And then a second Calico policy is Nginx, setting up the egress policy for Nginx to talk to IIS. Let's actually do the Nginx test first before we apply the policy. So you can see that from Nginx pod, I cannot run curl command to IIS. So now let's apply my Calico policies. One thing to note in here, when you're using Calico policies for Calico open source, you have to use Calico control or Calico CTL utility to deploy those. If you're using Calico Enterprise includes API server that does the manipulation and translation of Calico APIs, which allows you to use standard kubectl to run all the commands. And in fact, when you're using Calico Enterprise, we strongly encourage you to use kubectl because then you get all the audit logs from kubectl, any commands that you're running. So you can get that for your compliance, any audit compliance requirements that you have. So in my case, I'm using the Calico open source right now. So deploying those two policies. So let's repeat our Nginx test. Nginx now can talk to IIS. And previously we were able from Nginx, from netshoot to curl IIS. So at this point, we should not be able to because one of those policies, and I'll get to that in a moment, does not allow that. So if I take a look at into the ingress into IIS, you can see I have a selector where I'm saying if my run label does not allow the access only for those from those pods that do not have run netshoot label. Everything else should be allowed except for this. So that's one of the examples and how you can leverage Calico policy. Calico policies offer more operators. You can create quite complex conditions when you want to apply a policy, unlike, for instance, Kubernetes policies, which allow you very basic manipulations of how which pods can be matched. I believe this was lost. Yeah, there is a troubleshooting section. If you run into some issues, there are some hints for AWS for just a general troubleshooting in here. But this will conclude the session for today. If you guys have any questions, let me know.